Hi, everyone. All right, I've got 90 minutes. My name is Norbert. I'm working at Gevulot, and actually, it's interesting. I have ZK Cloud there, and I'm mentioning Firestarter in the title. Actually, Firestarter is the end-to-end implementation of ZK Cloud. It's just running in a permissioned way. We run the validators ourselves. So yeah, I'm going to talk about Firestarter, which we are launching basically today, tomorrow, this week, very soon. Funny thing is, in Athens, in the last ZK Accelerate, I was talking about our DevNet, which launched just before that. It's good to be talking about Firestarter now. Just to recap a couple of core things around what we are building, how we are building things. Decentralization is super important for us. So we want to create a viable alternative to centralized cloud providers, et cetera, that is fast, cheap, performant, and yeah, decentralized. So that basically no one can control where proving happens, so that we can ensure liveness guarantees, we can ensure censorship resistance, we can ensure trustlessness, fair distribution of workloads and rewards, and like we stay neutral. And like basically at Gevulot, we've been building along a vision where we believe in a ZK future where proving is fast, cheap, and really decentralized, and we've been designing ZK Cloud accordingly. Now, ZK Cloud is basically the first universal proving infrastructure for ZK. I'll talk about why it's universal on the next slide. But just to recap, it's basically a compute network optimized for ZK to drastically reduce the cost of proving for all participants and to maximize hardware utilization. We are looking to aggregate workloads from across the industry, and I'll also talk about that, how that's possible. And we are building it in a decentralized setup. Proving on Firestarter is actually based on a decentralized infra already. It's just the validator set that is centralized. I'll touch upon that. So a little bit about our design. We've got a proving layer, we've got an orchestration layer, and we've got a compute layer. The proving layer is universal because we support any proof system, meaning that we run provers in containers, in a Linux VM. You can deploy any prover program written in any DSL or using any proof system underneath. With this, that's why we say it's universal. With this, we are looking to aggregate workloads across the industry. And like integration-wise, it means we pre-deploy a bunch of the well-known names. I'll talk about that in a bit. But we also allow anyone to bring their own prover binary and easily deploy it in our network. Our orchestration layer is blockchain-based, basically, to stay neutral. There is a very minimal Cosmos-based chain underneath managing workload allocation, reward distribution, economics, such things. We've got node and network level orchestration to be able to handle complex workloads, like, I don't know, the segmentation of RISC-0 ZKVM, or like STAX proof tree construction. Yes, with this type of orchestration, we look to increase hardware utilization drastically, because on the other side, it's going to be translating to lower user costs. And we've got like protocol, like execution guarantees baked into the protocol so that, yeah, we can be reliably serving proofs to anyone. And the compute layer is permissionless, decentralized. One thing I'd mention here, I think it's important because with permissionless entry, you can ensure that you have a decentralized set. It's a good basis. But then to maintain the decentralization, it does matter a lot what type of workload allocation mechanism you use. In my presentation yesterday at Proto Layers, I was much more focusing on that. But I just want to say we went with the most neutral solution out there, meaning we randomly assign the workloads to our prover nodes. For that, obviously, to maintain performance, we have pretty high hardware requirements, minimum hardware requirements. But that's just to ensure that we can provide reliable services. And then, yeah, We have CPU, GPU proving, and we support any custom hardware as they become available, like Fabrics VPUs or any other. A quick roadmap to ZK Cloud. We had a DevNet running since March. We generated about 2.5 million proofs for about 400 different prover programs deployed on Gevulot. Firestarter is coming now. It's scalable and production ready. We didn't have the horizontal scalability on DevNet yet. It's coming with Firestarter, but the validator set is still permissioned. We're going to have a fully permissionless testnet called Deluge later this year, hopefully. And then first half of next year, hopefully Q1, we're going to have the fully permissionless ZK Cloud running. Now, I'm going to shift a little bit and talk about or introduce Firestarter. It's basically, as I mentioned, the end-to-end implementation of our ZK Cloud that is run in a permissioned way in terms of the validator set. But we are already powering it with a decentralized infrastructure. Node onboarding is already happening. We've got CPU and GPU workloads here as well. It's scalable to basically hundreds or even thousands of prover nodes, like horizontally scalable without the economics being really affected. So like without minimal overhead. So that's why I think it's important to mention that it's ready to serve production use cases, even very heavy workloads. And then compatibility-wise, you can deploy your own prover, or you can use any pre-deployed provers there. Yeah, a quick comparison. I think most of this is, I talked about most of them, I guess. Yeah, scalability is already there. Yeah, Firestarter is an incentivized network. I'll talk quickly about how you can join the network, but if you want to run a prover node, we apply random selection for workload allocation, and then we've got a fallback mechanism. In case of a prover failure, we automatically reassign the job to another prover, or we also allow like adding increased redundancy if you don't want to run the risk of a prover failure, a reallocation, and then doubling the time to get your proof. You can even increase redundancy and make it happen in one go. That will cost a bit more, obviously, but it's possible. Yes, we've got a free tier. We've got actually very decent pricing as well. I'll touch upon that too. So what's new? We learned from the DevNet, Nanos unikernels are not very friendly, even though they have some really nice properties. But we are moving away from Nanos VM and moving away from OS images to Linux VM and containers. So it should be much more easy to deploy any program, any prover and verifier program on Gevulot. It's scalable, as I mentioned. It's pay as you go, so you don't need to worry about idle time. You pay for what you use. And it's ideal, due to the orchestration there, it's ideal for parallel workloads like segmentation, continuation-based workloads, as mentioned. A quick recap of the life cycle. Like, let's imagine you already have a program deployed on Gevulot, or you want to use one of the pre-deployed programs. The user sends a run transaction to the network, it gets added to the mempool, it gets included in a block, and then randomly allocated to a prover node. And then, as soon as the prover completes the job, sends back the proof, it's already available for you to download, for the user to download. However, we need to do the verification internally, because only that's the only way for us to know that the prover did the job properly, the proof is valid, and then we base our reward distribution based on that. So that's what you see there. A subset of the prover nodes is selected to verify each proof. Obviously, they cannot be included to verify their own. And as soon as all have voted as valid, the proving workload is getting finalized, rewards are distributed, and if you as a user are fine with the verification and the guarantees Gevulot offers, even though that's not like our core thing, we more focus on proving. But if that's sufficient for you, then you can wait for that and then fetch your proof at the end of the process after the workload has been finalized on our network. Yeah, as I mentioned, Firestarter is going to be pay-as-you-go. We don't want teams to burn money with idle time and like idle compute. And I won't spend much more time on this slide, actually. I think the next one might be much more interesting. So the way it works on Firestarter, if you want to do proving on Firestarter, is you need to buy credits. 1 credit is 1 USD. You can even buy it with a credit card. Sorry, that's a weird joke. So you buy credits. And then when you send the proof request, you need to define certain parameters. How many CPU cores, how much RAM, how many GPUs you want to be allocated to your workload, to your job, and for how much time you want the program to be run by our nodes. And then you pay based on usage. Just a quick overview, like we have GPU and CPU nodes. The GPU nodes, 64 cores, almost 400 gigs of RAM, and 2 4090s each. If your proving workload uses the full capacity of this node, and you use it for an entire hour, then you pay 84 cents. So that's the total hourly cost of the entire capacity of this node. 2 4090s, 84 cents. That translates to $600 a month if we extrapolate it, and that's just, you pay for what you use. If you use it for 5 minutes, then you pay for 5 minutes. But it's just a more expressive figure, I guess. So for $600, that's 2 4090s, and the rest you get there if you were using it 24/7. For CPU nodes, you've got 96 cores and 700 gigs of RAM. The entire capacity per hour will cost 61 cents. It equals to $440 for an entire month. These are figures like, I don't know, about 90% cheaper than what's currently out there. Let's take 2 quick examples, like how would it look in 2 scenarios. So basically, you send your proof request to us, defining the hash ID of your prover and verifier program. That's the program we'll use to execute your inputs. You define the necessary resources, so CPU, memory, GPUs, and then the max running time. In case of the GPU sample or example that we have here, let's imagine you want 32 cores, 200 gigs of RAM, and 1 GPU. In that case, the most used resource, that's what we base our pricing on. The most used resource is basically your GPU, which is 50%. So we would take 50% of the entire capacity's cost, and since you only run this workload for 5 minutes, it's going to be 3 cents, 3.5 cents to produce it for you. In case of this CPU workload, you use the entire capacity. We could imagine this is actually a Polygon ZK EVM proof, let's say. You need the entire capacity to do the proving. Let's imagine it takes 10 minutes to do the proof. In that case, you'd pay 10 cents for that proof. Pricing, by the way, is based on USD. So even though we're going to have a token, your proof pricing is not going to fluctuate at all. You pay for what you use expressed in USD and then converted at the time of request submission to Gevulot tokens. Now, if you want to run a prover node, here are some more detailed specs. These are the minimum specs to run a node with Gevulot Firestarter. It's an incentivized network, so we are already onboarding node operators in touch with tens or if not hundreds of teams operating nodes in several networks. Let us know if you are interested. And also, just another way to be kind of exposed. If you want to participate in an incentivized network, but you don't have your hardware, then we've got a certain sized hardware on our own, like maybe 50 prover nodes or something like that. And then we are increasing that gradually. Of course, making sure that there are sufficient other participants in the network so that we maintain decentralization. But you can also rent a prover node from us and earn the incentives around that. You can scan the QR code and it will take you to the form where you can actually sign up. So I think whenever I practice, it's usually much longer. When I'm on stage, I'm usually finishing earlier, probably because I'm nervous. Thanks a lot for listening. If you've got any questions, I'm happy to answer now or outside as well. Yep, thanks a lot.
Thanks, Norbert. Congrats on achieving the new milestones. Any questions for Norbert? Okay. Actually, I'm curious. If you're selling the service 90% cheaper than AWS, can it still be profitable?
Yeah.
For Gevulot? Yes.
Yeah, I mean, not for Gevulot, it's gonna be profitable for node operators because like the user fees go to the prover nodes, and of course there will be network subsidy added on top so that we can maintain profitability there. Our core vision is that the largest bottleneck is the cost of proving. So we drastically wanted to reduce that to unlock a whole bunch of new use cases, or like just to simply make sure that cost is not a bottleneck to most of the teams. And then we'll try to take care of the rest by baking in properly designed economics in the network so that it's sustainable, but it's profitable as well. Yep.
Great. Thank you.
Thank you.